reactions that alkenes undergo. We're using propene as our example. One of the reactions we did yesterday was we put potassium permanganate, acidified potassium permanganate with cyclohexane and cyclohexene, and we only got a reaction with the alkene. And we weren't asked to say what was made. Well, now we're going to go through what actually would be made and how to name that. So, I know we had cyclohexene yesterday, but we're going to use propene again as our example because everyone's made models of that. When we acidify a solution of permanganate, so potassium permanganate usually, and we add it to it, the purple colour disappears, it decolorizes. That's our observation. Also what we notice, or should notice if we were careful enough, is that the organic layer, the bit that isn't water soluble, gets smaller. And this is because the thing being made is water soluble. It's what we call a diol. It's an alcohol with two OH groups. So all you really need to know is what happens and how to name it. So what happens is the double bond breaks, and in its place the OH ions from water create bonds here. So these both come out of water. Now, they don't come from the reagents. The reagents make it happen, but they actually come from water. Okay. So you get an OH on each carbon that originally did have the double bond. All right. And then we need to look at how we name it. So what we're looking for is we number it 1, 2, 3, 1, 2, 3, and see which one has the lowest combination for where those OHs are. So I've only numbered it backwards, as it were, because then I've got it on number 1 and number 2. It's ol because it's got OH, so anything that has an OH bound to a carbon, we are going to have carboxylic acids as well, which break this rule, but apart from them, anything with OH ends in ol. Because there's two of them, it's diol. We then look at the carbons that are on, number 1 and 2, so 1, 2 diol, and then we look at the carbon chain. 1, 2, 3, or 1, 2, 3 for our longest carbon chain. So it says propane 1, 2 diol. It's actually said propana 1, 2 diol. You say the E because it's part of the word. If there was a double bond somewhere, it would be propena diol. So you can have double bonds as well in these things, and you'd have to number where that is as well. So when you start seeing these really complicated names on the backs of packages for shampoo and all those sorts of things, you're starting to get an understanding of what's in it. If it's got ANE, you know that they're carbon-carbon single bonds in its carbon chain. Diol, two alcohol groups, that sort of thing. All right. So oxidation, and it needs quite a strong oxidizing agent like permanganate, will create a diol, and that's how we name them. Again, we're going to revisit alcohols in a lesson shortly, which will help with reinforcing this. The other really awesome use for alkenes is to make polymers, plastics actually, like the ones you're sitting on. The chairs you're made of came from an alkene, okay, that was then polymerized. Now remember, we've been writing the alkenes showing the angle of the carbon bond, okay, so showing the 120-degree angle. When it comes to polymerization, I want you to not do that. What you do is you draw each carbon-carbon bond like this, and then you put what they're bound to above and below. Which I think was a question someone had in an earlier lesson as to why we don't do it this way. We don't do it this way usually because this shows cis and trans better, okay? But we don't care about cis and trans in this case because we're going to go from double bonds to single bonds so everything can freely rotate, okay? So it's not important. But even better, this way will help us identify what the structure of the polymer is. So in this case, sticking with propene, which has got an older name, propylene, we are going to draw it out the way that some of you wanted to on a previous lesson. Up and down with what's bound to it. If we do it this way, it makes it much easier. These things are called our monomers, single units. And when we put billions and billions and billions of them together, and then we heat them and have a polymerizing agent, which is basically a catalyst, then they start reacting with each other. The double bond breaks and then whoops, I'm going to use this colour. One electron goes over here, one electron goes over here. That forces a neighbouring one to do the same thing. And when you've got two electrons in the same space, it forms a chemical bond. So this is what gets formed. And we end up with something that looks a bit like this. So the double bonds have become single bonds. I'm just going to put that back how it was. And naming these is really, really easy. The monomer is called propene or propylene. So the polymer that's made is called polypropene or polypropylene. And the bets are on a cold day, most of you are wearing some polypropylene. Okay, it's thermals. That's only thermals. So polypropylene is this. So they're named after their monomer. They're named after the chemical that they were made from, not the chemical they've become. So polystyrene has come from a chemical we call styrene. Okay? That sort of thing. So it has the word poly and it tells you that. Polyvinyl acetate, which is, or polyvinyl alcohol is another one, comes from vinyl alcohol or vinyl acetate. Okay? PVA, which is a glue. Alright? What you need to be able to do is show the polymerizing step. So put three monomers, notice I've used three monomers next to each other, then show what gets made. So double bonds become single bonds. Don't worry if you've got some of them upside down, it doesn't actually matter, because all of these can freely rotate. And you need to identify a thing called the repeating unit. That means looking for a pattern. When the pattern keeps repeating itself, that's what we call the repeating unit. Basically, you grab the middle monomer and you put brackets around it and put a little letter N next to it. That's how you do it. The other thing you have to be able to do is you have to be able to go the other way. So the way to do that is if you've got three drawn in a row, circle the middle two carbons and everything they're bound to, call that the repeating unit, draw it, and then put a double bond in the middle, and you now have the monomer. So you might have to go back the other way. Okay. You might have to, given the name of the monomer, name the polymer. You put the word poly at the front. You might, from the name, have to identify the name of the monomer. Take poly away. Or you might be asked to give the IUPAC name of the monomer. Which one of those is the IUPAC name? The one not in brackets, good, the top one. Okay. So, we've met addition. Markov-Markov's rule might apply. We've met oxidation. It makes a thing called a diol, two alcohol functional groups that are next to each other, by the way, not on the same carbon. And we've met polymerisation. Those are the three important reactions for alkenes that you need to know, and knowing about these will help you be able to finish the work in your homework as well. Any questions before I stop the film? Cool.